Hey, hi everyone. Today let's look at the LeetCode problem 155 min stack. So this is a very good design problem. Let's look into this problem now. Design a stack that supports push, pop, top, and retrieving the minimum elements in constant time. The implementation of min stack class should contain a min stack, which will be like an initializer, basically a constructor, and then you will have a push operation, a pop operation, a top operation, and finally a get min operation. So as you can see, and the expectation is that all of them will have a time complexity of order of 1. This is very important. Okay, so now if you see, right, a normal stack operation already would support push, pop, top, or maybe like even determine whether a stack is empty, things like that, or full, things like that in constant time. Now the requirement is that apart from that, it should also be able to let us know what is the minimum element in the stack in constant time. All right, now let's see, let's try to understand this problem in a better way and also see how to solve this problem. So now for explanation's sake, I'm just putting here, okay, let's go to the full screen mode. Okay, I'm actually putting an example where we are going to give a stream of inputs, okay? And imagine that this is your stack. So this is how your stack would be growing, right? So if you see here, it will start off with 8, 4, and imagine that this is the front of the stack from which you are actually popping out, or that is your top of your stack. Maybe let's put it that way. That's your top of the stack. So 2, 5, 10, 1, and so on. Okay, so a top of the stack would be like a order of 1 operation, and you can actually do a order of one operation using a normal stack, that is like for each of these pushes. Okay, and now if you see here, let's take one by one, right? Now I wanted to put across how the min works also. So now if I'm just using a normal stack, then in this case, when I'm inserting 8 is my minimum element. But when I'm inserting 4 is my minimum element. Okay, 2, same thing, 2 is the minimum element. Now when I'm inserting 5, my minimum element, to achieve the minimum element, I have to go through the stack and get 2 until 2 is my minimum element. And similarly, if after 10 is inserted, still 2 is the min element, and after 10 is inserted, 2 is still the minimum element. So then that means that I have to again go through the stack and find the minimum element. So that means if I just use a single stack, a normal existing stack, my min operation will be order of n, because I have to go through the stack, find the min element, and return it. Now let's think about another way to solve this problem. Imagine that I also keep track of a min stack. The idea of min stack is to actually keep track of the min element at that for the stack at that given point. Okay, now that's the intuition of this problem. So now let's start. So now the stack is so first element came, we'll just insert it to our current stack, and now we'll look at the min stack. If the min stack is empty, nothing, basically this will be, that means that there is no previous element, so of course we'll just insert the element. Now next 4 came in. So when 4 comes in, what we can do is we will see what is on the so this is the element, right? And what is the current top of the min stack? Current top is 8. So which is lower? That will be the lowest element at that given point of time in the stack. So of course 4 will go in. Okay, now what happens? Next 2 came. All right, now we will again check with the top of the min stack. So what is the minimum element, 2 or 4? Okay, so of course it's 2, so we'll insert 2. Now next 5 came in. Okay, at this point, what is the, like, we'll check the top of the stack, which should give us the minimum element of the stack at this given point of time. So 2 and 5. So what we will do is we will insert 2, which is the current top of the min stack. Okay. Now at this time, if I am actually querying a minima element, then we should return 2. Now 10 comes in. Again, we will look at the top of the stack and the current element. So 2 is the minima element. Now next, let's take the case where 1 comes in. So what is the minimum element here? So now 1 and 2. So 1 will be the minimum element. And as you can see, at any point of time for a get min operation, I will be able to return it in order of 1. Now let's write the code for this. So let's take how we'll be doing the push operation. So as you can see, we will need two stacks here. You could do it in a single stack and maybe like maintain a pair of elements where the first element shows the top of the stack and the second element shows the minimum element. For this explanation, I'm going to keep 2 stacks. Okay. So, and there will be another stack which will be maintaining the min stack. Okay. Basically, it will maintain the minimum element in the stack at that instance of time. Now, to start with, let's do the push operation. So to the stack, we'll just our stack we'll just push the value. Then, if stack is empty, sorry, if our min stack is empty, as stated earlier, empty, then we will push the element into min stack. So because there is no other element, right? So min stack dot push val. Okay. Else, what we can do is we can actually push the minimum of either the stack current min stack top, which shows the current minimum, or the current element that we are trying to push. I hope this is clear, because this is the critical piece where, as we had stated here, right? Take this example. Now we will see, because first case it was empty, so it would have pushed, it would have ended here. And now let's take this case. If that is the case, then when 4 was inserted, let's take a case when 4 came in. Okay, so we would have checked what is the minimum element. Is it the top of the min stack or the current value? So since it's current value, we inserted it here. Now, when we take a case of, for example, 5. So when 5 came in, 2 was the minimum element. Okay, on the top of the stack. So, but so 2 is less than 5. So we'll again add the top of the min stack element as the new top of the min stack element. Okay, so that's the push operation. Pop operation, if I'm just assuming that stack is, I'm putting an additional check here. Okay, if it is not empty, if it is empty, we'll just return -1. Okay, return -1. Sorry, I think we are not expecting anything, so let's only pop it if it is not empty. If it's not empty, then we'll come here. Since we are maintaining both stacks consistently, what we will have to do is we have to remove we have to pop both stack and min stack. So that is s.pop and min stack dot pop. Okay. Now let's take the top operation. So here, what we can do is, if the return not s.empty, so it's a normal stack operation, so I'll just put it that way, not empty, then we will just return s.top, basically the top element of stack, or we will actually return -1. Okay, now since the min stack is also consistent with the our normal stack, we can use the same thing, and we can always return min stack dot top or -1. I'm using s.empty itself here because both the size of s and min stack are maintained the same way. So as you can see, this operation will be order of 1, and the remaining stack operations as before will be order of 1. So let's now just try running this problem. Yeah, something is wrong here. Let's see. Oops, my bad. I should have put a push here. Okay, so let's see. Something went wrong. Let's see. Okay, this is the case. If it is not empty, sorry, my bad. If it's empty, we will push this one, and if it is not empty, we'll push this one. Okay, sorry about this. Okay, let's just run this once more. Let's submit it. Okay, so this looks good. So that's it for today. Thank you.